Okay, let's dive right into this explainer. We are looking at two completely different, yet seriously impressive marvels of modern engineering that quietly power our world. On one hand, you've got the tangible, raw physical power required to move thousands of tons of steel across the Earth. And on the other, the immense computational capacity needed to parse millions of lines of code in the cloud. And by some wild serendipitous coincidence, the companies behind these feats share almost the exact same name, MiniMax. So let's explore how these twin titans handle extreme stress, massive capacity, and efficiency in their totally different domains.
Now, what's really interesting here is the stark, honestly kind of amusing contrast between rugged physical railway hardware and a cloud-based digital brain. On one side, we have MiniMax Technologies' MTQ-Z50 series. This is a heavy-duty, industrial-standard DC-DC converter. Its entire purpose in life is to take the chaotic electrical power bouncing around on a moving train and deliver a clean, perfectly stable 50 watts to critical control electronics. Then, on the flip side, we have MiniMax M3. Now, this isn't hardware at all. It's a cutting-edge large language model built by an AI lab, and it's designed specifically for software engineering. So, instead of processing raw electricity, it's processing raw information, up to 1 million tokens of data in a single thought. They share a name, but they literally represent the two pillars of our modern existence: physical movement and digital logic.
First, let's ground ourselves in the physical world. Check out the MiniMax MTQ-Z50. It's housed in what they call an industrial standard quarter brick package, and it's capped with this heavy-duty black-finned heatsink. This converter is designed to endure unyielding physical stress. You know, when you're designing components for rolling stock, meaning trains, locomotives, light rail, you aren't just designing for some cushy, air-conditioned server room. You are designing for an environment that shakes, rattles, and goes through massive temperature swings. The base plate of this device can operate safely from a freezing -40 degrees all the way up to a blistering 105 degrees Celsius. With its non-conductive black plastic base and aluminum top plate, it's built to literally survive the elements of transit.
So here is the absolutely crucial number for this little block: 92%. It achieves up to 92% efficiency. Now, why does that matter so much? Well, in power conversion, any percentage point that isn't converted into usable power is lost as heat. And if you're packing auxiliary converters, communications gear, and control electronics into tightly sealed metal boxes on a train, heat is your absolute worst enemy. It degrades components and causes system failures. By hitting that 92% efficiency mark, the MTQ-Z50 minimizes its own thermal footprint. It improves the overall system power density, which basically means you can do way more with less space, all while keeping literal trains from crashing.
It survives these harsh environments using a really robust suite of physical protections. It acts like an unyielding shield against electrical chaos. Power lines on trains are notoriously dirty, right? They suffer from massive surges, drops, and spikes. So this converter has a super wide input range, handling anywhere from 43 to 101 volts, or even 66 to 160 volts depending on the model. But more importantly, it has this whole arsenal of defense mechanisms. Voltage drops too low, it initiates an undervoltage shutdown. Fault on the output, it has continuous short-circuit protection using what's called a hiccup mode. That means it'll keep safely pulsing until the short is removed rather than just melting down. It even has over-temperature protection if the base plate hits 110 degrees Celsius. It's practically bulletproof.
Right, so you can't exactly just slap a power converter into a passenger train and, hope for the best. This brilliantly illustrates its reliability. It carries the EN 5055 railway certification, which is the absolute gold standard for electronic equipment on rolling stock. It survives intense shock and bump tests and rigorous fire protection protocols. Add in 3,000 volts of alternating current reinforced isolation, plus those crucial UL safety approvals, and you've got a component that guarantees onboard communications won't fail when you need them the most to keep your daily commute safe.
Okay, so we definitely know how to handle the physical stress of powering a massive locomotive, but what happens when the load isn't electrical but cognitive? What happens when the infrastructure we rely on isn't a train but sprawling networks of legacy software? Well, let's pivot and see how this builds into our digital world. That brings us to our second MiniMax, the Shanghai-based AI company that's been quietly building a huge reputation in the developer community. Enter MiniMax M3. This is a coding-focused AI model boasting a massive 1 million token context window that prevents your complex code bases from completely derailing. To put 1 million tokens into perspective, that's roughly 750,000 words. Most standard AI models tap out at around 128,000 tokens.
But with M3, you don't have to chop your code into tiny little pieces to feed it to the AI. You can drop an entire massive code repository into the prompt all at once. This whole repo awareness means the AI isn't just looking at one file in isolation. It can actually see how a function in your database layer connects to a variable way over in your user interface layer. It completely eliminates the blind spots that usually plague smaller AI models.
And it doesn't just have large capacity, it absolutely smashes the software benchmarks. Just look at these SWE-bench Pro scores. This is what has the developer community buzzing. And keep in mind, this isn't some simple multiple choice test. It's a brutal, real-world benchmark based on actual, difficult issues pulled right from GitHub. The AI has to read the code, understand the bug, and write a working patch. MiniMax M3 hits a 56.5% pass rate. That handily outperforms giants like GPT 4.5, which is sitting around 39%, and Gemini 2.5 Pro at 47.5%. Just a short time ago, we were celebrating models getting 20% on this test. M3 is proving it can do real, heavy-lifting software engineering work.
But here is the jaw-dropping value proposition: the cost. Look closely at this table, because it fundamentally changes the economics of AI. To process 1 million input tokens on GPT 4.5, you are paying $75. For that exact same 1 million tokens on MiniMax M3, you're paying 20 cents. 20 cents! Actually, let that sink in. And for the output, it's just $1.10 compared to $150. When you're running high-volume workflows, like an AI reviewing dozens of pull requests a day, that cost gap compounds incredibly fast. It makes enterprise-scale AI code analysis economically feasible for literal fractions of a penny compared to the competition.
So what does this all mean? Well, this massive cognitive load capacity translates to some incredible real-world applications. Imagine automated code review, where you just feed the entire repository to M3 to check a pull request's systemic impact. It takes minutes instead of days. Or think about bug triage. Instead of guessing, you just hand the AI the error logs, the stack traces, and the source files all at the exact same time so it can pinpoint the root cause. And for large-scale refactoring, M3 can see the whole picture at once, updating deprecated APIs and restructuring dependencies in a single, coherent pass. It's a real game changer. So, bringing it all together, we've seen how the MinMax hardware relies on physical resilience to keep our trains running, while the MiniMax AI relies on digital capacity to keep our software flawless. It's really two different paradigms of problem solving. The DC-DC converter solves its problems with robust hardware, heat sinks, potting material, and rigorous thermal management. It's all about surviving a harsh physical environment. The M3 model, on the other hand, solves its problems with massive contextual awareness. It's about absorbing a chaotic, sprawling digital environment, like thousands of lines of legacy code, and making logical sense of it without losing the thread. Both are specialized, incredibly efficient, and absolutely crucial for their specific types of infrastructure. I want to leave you with this final thought to ponder as we wrap up this explainer. Think about the nature of power and infrastructure in our rapidly evolving, interconnected world. We rely absolutely on both the physical components that move us safely from city to city and the digital components that keep our global software ecosystem from collapsing, the 50-watt converter and the 1 million token AI. As these two realms continue to overlap, which of these advancements excites you more? Is it the perfection of physical resilience or the boundless expansion of digital capacity? Think about that the next time you hop on a train or write a line of code. Keep your curiosity switched on, and I'll catch you next time.